So in probability, we have several rules that are going to help us out along the way. And the first of those is called the general addition rule. Okay, the general addition rule is used when I'm looking for the probability of something or something else. However, in statistics, or has a different meaning. Usually you think of or as like when you go to a restaurant and a waiter says, "Would you like soup or salad?" They're talking one or the other. Okay? However, or for statistics is one, the other, or both. And it's that both that we have to think about here when we're talking about the general addition rule. This kind of or, what we mean in statistics when we say or, is we mean kind of like cream or sugar. It's okay for you to say both. Okay? One, the other, or both. And yes, this formula is on the formula sheet, but the formula is if I want the probability of A or B, okay, this little sign right here, this little U, means union. And it stands for or. But it's the sign for union. But same thing as or. A or B. I take the probability of A and add to it the probability of B. And this is it if the two are mutually exclusive. However, if they're not mutually exclusive and they both can happen at the same time, then I want to subtract the probability that they are both happening at the same time, because that's already accounted for in these two. So the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. That's what this stands for intersection. And it is and. And you can kind of remember that because and has an N in it, and so the N is and. Okay, but this is the general addition rule, and yes, it is on the formula sheet, and it looks just like this on the formula sheet. The most helpful tools in calculating probability is a two-way table, and I hope that you remember those from chapter 1, but we're going to make one now to talk about this data in this example. So, what is the relationship between educational achievement and home ownership? A random sample of 500 people, so that would be our total, who participated in the 2000 census was chosen. Each member of the sample was identified as a high school graduate or not, and as a homeowner or not. Okay, I can see right now that these are my two categories that I'm looking at. So my two-way table is going to be either they were a high school grad or not. And I'm just saying HSG here. Okay, and either they were a homeowner or they were not a homeowner. And hopefully your table looks a little bit nicer than mine. Okay, so then I know that my total that goes in this corner over here is 500. Because remember, the total for my rows would be these two, and the total for my columns would be these two, and the 500 is the overall total. So if I added these two up or I added these two up, I should get 500. Then I look here. It says overall 340 were homeowners. Okay, notice that it doesn't say like 340 were homeowners and high school graduates. It's just talking about homeowners. That tells me that that is the number of just homeowners. So I find the homeowners and I go all the way. It doesn't split it down into my categories here, but it tells me the total number of homeowners. 310 were high school graduates, so that's the total for this column. And 221 were both homeowners and high school graduates. So I find homeowners and I find high school graduates and where they intersect. Okay. Now, thanks to these numbers, I can go ahead and fill in the rest. If the total was 500 and 340 were homeowners, then that means 160 were not homeowners. Likewise, if 500 were the total and 310 were high school graduates, that means that 190 of them were not high school graduates. Okay, now based on these numbers, I can fill in the people who were high school graduates and not a homeowner, because I would subtract these two and get 89. And then I could subtract these to find the homeowners who were not high school graduates and get 119. And then my final number, I could do any number of ways, but I'm going to get 71. And remember my table, I should be able to add these two and get this, add these two and get this, add these two and get this. And likewise, these two should be that, add these two and get that, and add these two and get that. Okay, so suppose we choose a member of the sample at random. Find the probability that the member is a high school graduate. Okay, so remember, probability is just the number of times our event occurs over the total number of times in the sample space. So our sample space has 500 people in it. Okay, out of those 500 people, there are 310 that are a high school graduate, because I look at this column right here. 310 are high school graduates. So I say 310 out of 500. And remember, you don't even have to simplify your fraction. You can leave it just as it is. The one thing I want to make sure that I do, that I forgot to do here, is always define our events as what's happening. So we're going to define event A as being a high school graduate. And I always want to define these before I ever start, because it makes it easier for me to actually write out my answers. High school graduate. And we're going to define event B as being a homeowner. Okay, so here I would actually write this as the probability of event A is 310 out of 500. Okay, so this one is wanting the probability that the person is a high school graduate and owns a home. Okay, for and, that means both of them have to be true. So there's only one category up here that fits that. The only time when they are a high school graduate and they own a home is this one right here, which means that the probability of A and B is equal to 221 over 500. Okay, finally, this one is a high school graduate or owns a home. That one is a much bigger number, because remember, or means it can be one, the other, or both. So the probability of A or B is equal to the probability of A, which means they're a high school graduate. So that would be 310 over 500 plus the probability of B, which is that they're a homeowner, so that's 340 out of 500. And then I have to subtract the probability that they do both, that they are a high school graduate and they own a home. We already know that's 221 out of 500. So when I do the math, I get 429 out of 500. That's using a two-way table. It's very, very easy to do as long as you make your table correctly. The other thing we use when talking about probability is a Venn diagram. I am sure that between language arts and previous math classes, you've seen several Venn diagrams. So this is what they look like when we're talking about them in terms of probability. Okay, if I want to use a Venn diagram to display the complement of event, let's say that what's inside my circle here is A, then the complement of that is everything except what is in my circle. Okay, that would be the complement, because the complement means not A. So if A is represented by the things in the circle, then not A would be everything around the circle. Okay, if I'm talking about two mutually exclusive events, meaning mutually exclusive means that they cannot happen at the same time. So if I have event A and I have event B and they're mutually exclusive, they don't have any overlap at all because they are mutually exclusive. They cannot happen at the same time. So there's no overlap because that's what the overlap in event diagram represents. So like for this one, if I'm talking about A and B, they overlap, and the and is represented by the overlap. This is the only time when they both occur. So that's the only space. Things that occur in there are the only things that could be represented by A and B. And finally, if I wanted to represent A or B, okay, I have my two events. They overlap, but because I'm saying or, remember that is one, the other, or both. So anything that is in either of the circles and any part of the circle counts as A or B. Okay, versions of these diagrams are also on page 305 in your book if you feel like you need to look at it a little more than the ones I have drawn here. So let's look at this example. It's going to ask us to use a two-way table and a Venn diagram, and it is all about phone usage. Okay, according to the National Center for Health Statistics, in December 2008, 78% of households had traditional landline phone, 80% of households had cell phones, and 60% had both. Suppose that we randomly select a household in December 2008. Okay, so even though I don't have actual numbers like we did in our earlier example, I can still make a two-way table because I can make a two-way table out of proportions and percents just like I can out of counts and frequencies. So here, if I'm looking up here, I have cell phone and no cell phone. And I have landline. And I have no landline. Then I always have my totals around the edges. So it says that 80% of households have cell phones. So that would give me, that's the total percent out of. Okay, and it tells me that 60% had both. So that tells me that this is 0.6 because it's in my both square. And it tells me that 78% have traditional landlines. So of the people who have landlines, that's 0.78. Since I'm talking about percents and proportions, my total is a little different. It's not the total number of people we interviewed. It's 1 because that's the largest amount. All of my proportions here should add up to 1. So that means I can go ahead and fill in the rest of these. This must be 0.22. This must be 0.2. This must be 0.18 because I have to add these two to get that. This must be 0.2, which means this one must be 0.02. And you can see that I can double check myself because if I go this way or this way, it's still supposed to be 0.02. Okay, then it wants us to construct a Venn diagram. So I draw my square to represent everything in my sample space. I draw this circle to represent people who own a landline. And I draw this circle to represent people who own cell phones. And then I can fill in my numbers. I know that the percentage of people who own neither a cell phone nor a landline, so that would be all of these people out here who own neither. That's 0.02. Okay? I know that the percentage of people who own both is 0.6. Okay, so this is the percentage of people who own a cell phone but not a landline. Because if these are both, then these are cell phone only. So that would be 0.2, because this cell phone, no landline. And this is landline, no cell phone, so that would be 0.18. So notice here, my numbers are made up not from my totals around the edges, but from my values on the inside. So the notes have 3 questions on them. So let's go ahead and define our events, and I'm just going to write them over here to the side so that we can still see these. Let's let A be that the person has a cell phone, and let's let B be that the person has a landline. Okay, the first question on the notes wanted to know the probability that the household has at least one of the 2 types of phones. Okay, at least one. So that's basically cell, landline, or both. So that would basically be the probability of A or B. That's at least one, the other, or both. So because they're already in percentages, these are basically probabilities. So I do not have to put them in fractions. One, the other, or both. I say 0.8 plus 0.78 minus the both, which would be 0.6. And when I add these together, that is 0.98. So there's a 98% chance that they have at least one type of phone. If I'm doing this from here, and this is supposed to be 18, but if I'm doing this from here, all I have to do is add these 3 numbers together. Because this 0.18 does not include, it's 0.18, not 0.78. So it doesn't include the people who own the cell phone too. Or own the cell phone too. So if it's a Venn diagram and I just add my 3 segments together. Okay, question number 2. Find the probability that the household has a cell phone only. Okay, so this would be just the probability that they have a cell phone only. So a cell phone and no landline. And we know that that is this box right here, and it's also this segment of the circle. So either way, it is 0.2. And the other question is, find the probability that they have neither type of phone. So that means they don't have a phone at all. So no landline or no cell phone and no landline. Okay? That's going to be this area out here, or it's going to be this square right here. So there are all of my probabilities from this 2-way table and this Venn diagram.